Hey, hello guys, in this video we're going to talk about science, and we all know that science is about fun, so please pay attention and listen that we have an interesting story to tell you about. Since ancient Greece, humans looked up at the things around them and wondered about the composition of matter and other phenomena. Philosophers like Democritus and Epicure needed to explain reality in a philosophic way, so they imagined that matter was made of tiny little particles that they called atoms. Well, the word atom comes from two Greek words, a, which means no, and toma, which means I could. So basically, in ancient Greece appeared the idea that those tiny particles were the fundamental structural unit of matter. However, this concept was based in philosophic needs, not experimentation, so people found hard to believe in this theory. It was not until the beginning of the 19th century when the first atomic theory based on scientific observation appeared. A chemist called John Dalton stated that atoms were like particles with a ball shape. He formulated simple statements to support his theory. The first one is that matter is made by atoms, and atoms are indivisible and indestructible, so you cannot take an atom and divide it into parts. The second statement says that atoms from the same element have the same weight and properties, and atoms of different elements doesn't have the same weight and properties. Finally, the third statement says that different atoms can combine in different proportions to form different compounds, and that's the origin of Dalton's multiple proportions law. At the end of 19th century, a physicist called Joseph Thomson applied a magnetic field on cathode rays emitted by hydrogen and noticed that those rays were deviated. That phenomenon was very strange for him because the observations didn't fit with Dalton's model, in which charges didn't exist. So after thinking a lot, Thomson concluded that there were subparticles negatively charged, and he called them electrons. The discovery of the electron was very important because it was useful to explain the electric nature of matter. And from that, he formulated his own atomic model. The new model consisted in a central ball positive charge with smaller negative particles and electrons surrounding the positive one. This model was effectively to explain the origin of electric charges in the atom, but there were still some phenomena for which the theory was not sufficient to explain.
But the Thomson model was not correct. In 1990, Ernest Rutherford made an experiment that he called the Geiger-Master experiment, in which he was trying to prove the Thomson model. The experiment consists in using an alpha ray emitter and a funnel of gold. The alpha ray should hit the pole, but that was not the case. Rutherford failed and actually proved that the atom was not like a pudding. He saw that the alpha particles were not being deflected by the ball of gold. Instead, these particles went through the ball with some small deviation. These results made no sense to Rutherford, so he thought that maybe atoms are in its majority empty space. The Rutherford model insists that the atom has a nucleus, and this nucleus is a positive charge, and around this nucleus are the electrons which are orbiting the nucleus. Between the two charges there is a big gap where is nothing more than empty space. This model helps to open a new concept about the structure of matter. These three models were the beginning of a long and complicated history in the understanding of matter and how matter behaves.
Hey guys, thanks for watching this video. If you like, don't forget to subscribe. Also don't forget to leave some comments below. And we will be uploading more videos every time our teacher wants to scream with us.